Welcome to Unit 3, Lesson 2, the unit circle. So today we're going to be talking about the unit circle and the coordinates that go with it. And there's a bit of memorization in this section of this unit that you'll need to take away, and I'll talk about that throughout the lesson. So when we talk about a unit circle, we're talking about a circle with a radius of 1 unit. And it's a circle of radius 1 unit with center at the origin on the Cartesian plane. Okay, so this is an example of the unit circle. Notice how the points here go 1, 0, 0, 1, negative 1, 0, 0, negative 1. Those are 4 of the main points. Don't forget that this represents 0 or 2 pi, half a pi, 1 pi, and then 3 over 2 pi. Now, if we look at this circle on the right here, we're going to talk about how we get the equation of the unit circle. So if you see line segment OP, that's our radius. It's going from here to here. Our radius here on the unit circle is always 1. And then the line segment PA, which is this one here, PA, is superimposed right angle triangle. Here's our angle theta on the inside here at O. And notice that this A coincides with the x-intercept. Okay, and that will be true of all points on this circle. Y will have a corresponding coordinate somewhere along the y-axis as well. So what we can say is OP squared is equal to OA squared plus PA squared. Notice that this looks something like your Pythagorean theorem. C squared is equal to A squared plus B squared. So our hypotenuse is 1, and then we're looking at the absolute value of these coordinates to give us the correct answer. So when we simplify it down, we would just get 1 is equal to x squared plus y squared. So you can find any coordinate on the unit circle if you have at least one of the coordinates, because you know that the radius will always be 1. Below this we have an example. It says determine the equation of the circle with center at the origin and radius of 2. So you just use your general formula, x squared plus y squared equals the hypotenuse squared. And in this circumstance, the hypotenuse is 2. So 2 squared is 4. So that would be our general formula for that. You can try this example for yourself. Just draw a basic unit circle and include a radius. Something that we can do with this information is determine the coordinates for all points on the unit circle that satisfy the conditions given. So it says here the x coordinate is positive 2/3. That means that it needs to be in the positive x realm, or from 0 this way. Remember, all x's on this side would be negative. So we have a value of x is equal to positive 2/3 or 0.66. Once we know that, we can just plug it into our formula to figure out what y equals. So we have 2/3 squared plus y squared equals 1. Solve for y, okay? So isolate this away. Remember, 1 is equal to 9 over 9 in this circumstance. So you're just going 9 over 9, subtract 4 over 9. That will give you y squared is equal to 5 over 9. And then you're going to take the square root of this. So root 5, because it's not a perfect square, over 3. And we can say it's either positive or negative, because in this example, we have a value of 2/3 for the value of x here and here. So each of these will have a response. So in quadrant 1, the coordinates would be 2/3 and root 5 over 3. And in quadrant 4, it'll be 2/3, and then you see here your y value is negative. Using the same formula, you can also find the x coordinate if you're given the y coordinate. So we have this y coordinate, or excuse me, this coordinate x, negative 1 over root 2. So again, we just need to apply the formula. And the formula is x squared plus y squared equals 1. Same thing, just square the value of y. and then subtract 1/2 from both sides. Don't forget that 1 is equal to 2 over 2 over 2. Sorry, my pen's not working. And so we subtract 1/2 from both sides. 1 minus 1/2 is, of course, 1/2. And now again, we have that x squared value. So you need to take the square root of both sides, and that will give you 1 over root 2. And you might be saying, why is it negative here? Well, just remember which quadrant we're in. We're in quadrant 3, and x is negative in this quadrant. So your point then becomes negative root 2 over 2, negative root 2 over 2. The other thing we can do is we can be given coordinates on the unit circle and asked to confirm that they reside there. So in that situation, because it says in the unit circle, we know that this value is going to be 1, a radius of 1. So if you're given the x and y coordinates, you can just plug those in and solve for it to see if the left-hand side of your equation equates to the right-hand side of your equation. In this circumstance, we get 10 over 16 equals 1, which of course is not a true statement. If you can please try example B and fill that in with the correct response and see if these two coordinates fall on the unit circle. If they do, your left-hand side would equal your right-hand side. Now, we've talked briefly about the unit circle in class, and we have some common points on it. So here we have multiples for reference angles. Now, some of the reference angles that we'd be using that fall on the unit circle could be 0, 30, 45, 60, and 90, which would all, of course, fall in quadrant 1. Those corresponding angles would also fall here, so like 120, 135, 150, 180. So basically we're going 30, 45, 60 in each quadrant to give us all our units on the unit circle. Now, remember the denominator, we talked about this in class. The denominator determines how many pieces you're cutting your pie into. So if you have 1 pie from here to here, and the denominator is 3, you're going to cut that unit circle into 3 pieces like that. Oh, I missed the point there. You're going to have 3 pie pieces, of course, all equal. And then corresponding on the bottom, you will also have the same. So notice that 2 pi is 6 pi over 3, right? This should look familiar to you. So what I'd like you to do on the right-hand side is start at 0 and label the pi over 6 units all the way around the unit circle. I've put little dashes there for you to indicate to you which ones you should try and label with pi, multiples of pi over 6. So using the unit circle, we can also determine coordinates expressed as basic trigonometric ratios. So this goes back to that SOHCAHTOA that we talked about in class, where sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So because we have this right angle triangle superimposed on the unit circle, we have our angle theta here, and this is our opposite side, and this is our adjacent side. So once you know that and you have an xy coordinate, you can determine the coordinates of this value by using your trigonometric ratios. Now, there's a little trick here where the cosine of theta is equal to your x value and the sine of theta is equal to your y value. The tan of theta is equal to the ratio of y over x, or opposite over adjacent. So you might need to do a bit of fraction work here, but that's the basic way that we can figure out the coordinates of the unit circle, is by using these basic trig functions. Now, don't forget that if you're leaving them in radicals, those are perfectly good answers. this is how we would do a question like this. We have the point A, negative 12 over 13, negative 5 over 13, is on the unit circle. Determine the value of sine, cosine, tan. So I just drew it over here. I gave you an idea. Negative 12 over 13, that's our x value. It's just approximate. And then negative 5 over 13 is our y value. So our point is here. And when you draw the angle down, you get this theta created by that because you have a right angle triangle here. So here's our opposite, here's our adjacent, and it says it's on the unit circle, so our hypotenuse is a value of 1. Now I've just taken this and redrawn it so that it's just a little bit more clear for you to see where I'm getting these values. So let's start with tan of theta. We have tan of theta is equal to opposite over adjacent. Now here's where I was talking about where you might need to do a bit of fraction work, okay? It's opposite over adjacent. So we have negative 5 over 13 over negative 12 over 13. And remember to divide two fractions. You're just going to flip and then multiply across. Now, of course, 13 divided by 13 cancels, and you're just left with negative 5 over negative 12, which of course is equivalent to positive 5 over positive 12. Or y over x simplified. Now, don't forget that in the third quadrant, tan is positive. So this will help you to confirm your results are correct by the fact that you got a positive value for tan. Now, remember, all of the functions are positive here. Sine is positive, cosine is positive, and tangent is positive. So the other two answers, sine and cosine, we should get a negative response. Now, our cos theta is equal to adjacent over hypotenuse. Our adjacent side is negative 12 over 13, and our hypotenuse is 1. Notice that this is just the x coordinate. And then our sine is exactly the same, but using a different side. So opposite over hypotenuse, and negative 5 over 13. We have a pretty good indication that we've done it correctly because we have a negative symbol on both cosine and sine, and our tangent has become a positive value. For questions 5 and 6, I'm going to talk about the unit circle and show you what that looks like. I'd also love for you to look at this 5-minute video on YouTube. It's called Unit Circle, Radian, and Coordinate Points. I'll also post the link for that, but she gives some really good pointers about how to memorize the unit circle, which is something that you need to do. I'll try to point out a few of the tricks as we go through it, but take the extra few minutes and watch that video. It will really help you in the long run. So in question 5, we're looking at what are the coordinates for each p theta for multiples of theta equals pi over 3 on the unit circle. And dun dun dun, here it is, the unit circle. So it looks big and scary and complicated, but sorry, I'm trying to figure out how we can fit it all in here. I might have to move my page around. It looks big and scary and complicated, but it's not, okay? All you need to really recognize is that we have some common angles. We have 0, 30, 45, 60, 90. And then this is, again, 30, 45, 60, 90. Okay, it's in a pattern. And you can see here, we have pi over 6. Okay, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And we have some patterns here. You can see here, starting at 30 degrees, we have 1 pi over 6, 2 pi over 6, 1, 2, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. That gives us 1 pi, okay? Now, I want you to notice something about the coordinates for the corresponding angles. You really only need to memorize, of course, the ones that hit 0, 90, 180, and 270. Those are going to be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Take a look at the coordinates for 30 degrees. So here we have pi over 6. Notice that the coordinates for pi over 6 are root 3 over 2 and 1/2. Now, let's find some corresponding angles on the unit circle that have matching coordinates, but the signs are changed. So our first example would be at 150 degrees, it's negative root 3 over 2, 1/2. And then also at 210 degrees, negative root 3 over 2, negative 1/2. And then finally over here at 330 degrees, or 11 pi over 6, root 3 over 2, 1/2. All of these angles, they have similar properties if you look around your unit circle. So find the pattern. You need to remember these three coordinates. Root 3 over 2, 1/2, root 2 over 2, root 2 over 2, and then this one just flipped, 1/2 root 3 over 2. If you know those three, you know the whole unit circle. All you have to do is change the positive or negative on the x and y value depending on the quadrant you're in. So of course, here we have positive x, positive y. Here we have negative x, positive y. Here we have negative x, negative y. And here we have positive x, negative y. So don't forget those basic rules, and this will become a really simple thing for you. So as I said before, this is your unit circle, and you do need to have this memorized. It's not provided in the formula booklet for your exams, so you'll need to reproduce this at the start of your exam so that you're able to do your questions with it. So in your sample question, it says, what are the coordinates of each p theta for multiples of pi over 3? So you're just going to look for the pi over 3 coordinates, 1/2 root 3 over 2. Okay. Here's the next one, 2 pi over 3, negative 1/2 root 3 over 2. Down here at 240, negative 1/2 negative root 3 over 2. And then finally here at 300, 1/2 negative root 3 over 2. So all those coordinates are there and available for you, and you can just go through that second example problem, question number 6. Using the unit circle, going to figure out a way to go back and forth here. So using the unit circle, we have cos theta is equal to root 3 over 2. Now I want to remind you from a little bit earlier in the lesson, this is equal to our x coordinate. So we're looking for x coordinates where cos is positive and the answer is root 3 over 2. So if you look on your unit circle, we have x value of root 3 over 2 here, so 30 degrees. And then we also have another one here, root 3 over 2, or 330 degrees. Okay, all of these other examples are done exactly the same. So if you're not sure where I'm getting my answers from, just compare it to your unit circle values. I assure you they will end up exactly where I placed them. Now, the other thing that we can do is use the unit circle to determine the value of the given angle. So here we have x is equal to cos of 2 pi over 3. So you just want to find 2 pi over 3 on your unit circle. It's right here at 120 degrees. And it's at the cosine, so your cosine is going to be negative 1/2. Now, the only place where you might get tripped up a little bit, the remainder of it is just reading it right off your unit circle. But when you have your tangent, don't forget that you're finding y over x. So here, 7 pi over 6, I'll just show you it on your unit circle. It's 210 degrees. So here's your coordinates here. We're going y over x. So we have negative 1/2 divided by negative root 3 over 2. You're going to flip and multiply. So negative 1/2 times 2 over root 3. That will give you 1 over root 3. And then we're going to take this radical out of the bottom. So you're going to multiply top and bottom by root 3 over root 3. And your final answer will be root 3 over 3 for the tangent. Okay. There's also additional examples here on the bottom. So just go over this and make sure that you can find the values that I've found. And if you have any questions, please do ask me. Please note on E, F, and G that these are negative angles. So that means you're starting at 0 for example, E is negative 4 pi over 3. So you're going to start here and you're going to count back by pi over 3 radians. So negative 1, negative 2, negative 3, negative 4 pi over 3. So it works exactly the same as degree angles. You just count backwards from here, but go by radians instead. Beyond this, you have some practice questions, and I believe that you can go through all of them and get yourself prepared for class tomorrow. Use your unit circle to help you answer your questions, and I think that you will be very successful.